Hello, and right now what we are going to be starting to talk about is how we can use sine and cosine to find side lengths in triangles. In our last lesson video, we talked about how to use tangent. In this case over here in our notes, this red T stands for tangent, and we learned that the tangent represents the opposite side over the adjacent side. So we would want to find our angle, label what's opposite of it, adjacent to it, and then we can use that. And we've already learned how to do that, so we're going to kind of move on just a little bit here. We are going to learn how to use sine and cosine. So if you look at SOHCAHTOA, S-O-H-C-A-H-T-O-A, we've already done tangent. Now we're going to look at if we wanted to use sine. Okay, sine is going to have a relationship of the opposite side over the hypotenuse. And again, we want to make sure we're labeling these sides so we know which ones we're going to use, and we'll do that in our examples. And then cosine is the adjacent side over the hypotenuse. So let's go ahead and take a look, there we go, at how that's going to work. So these first four examples, I'm just going to tell you we're going to use the sine ratio, okay? And if you look, how I know that is first thing that I'm going to do is I'm going to identify my angle, okay? Then I'm going to identify the three parts of the triangle. So I have over here, that side is opposite of my angle, so this is going to be opposite. Across from the right angle is always the hypotenuse. And the angle that is, or excuse me, the side that is right next to the angle is the adjacent. And if you notice, the two pieces of information that we are given is the opposite side and the hypotenuse. So what we're going to do is we're going to write an equation, okay, because we know that the sine is the opposite over the hypotenuse, and it's always the sine of the angle. So we're going to say the sine, in this case our angle, and remember in right next to our sine it's always the angle measure, equals opposite, in this case opposite of it is x, and the hypotenuse is 12. In order to solve this, I always think about it as a proportion, since we also just finished a unit on proportionality, and you can think about it two different ways. You can butterfly, or you could just multiply both sides by 12. I'm going to do the butterfly method because that's what we have been doing in our last chapter. So if we butterfly it, have 1 times x is x. And if I multiply 12 times the sine of 47. Okay, remember the sine of 47, going back to what we learned yesterday or earlier today in our lesson video, the sine of 47 is the relationship between that opposite and hypotenuse side, and it's a decimal value. So the sine of 47 is a number. It's not some variable or magic something that you don't know what it is. It's a number. Well, we stop at 4 digits. It's a decimal, okay? And then in our Desmos calculator, you want to make sure you have that open. You're going to take 12 times the sine of 47, and you should get 8.78. Make sure you're putting that into your calculator and doing it. Make sure you know how to enter it correctly in Desmos scientific calculator. Looking at number 2, we're going to do the exact same thing. We know it's sine because I've already told you that. Here's my angle. Across from it, that's opposite of it. So x is opposite of it. And across from the right angle is our hypotenuse. And we don't have any information about our adjacent side. So we can say, since we have opposite and hypotenuse, we are going to use sine. So we're going to say the sine of 16, and remember the trig function is always attached to the angle measure, so you always want to put that angle right next to the trig function. So you have the sine of 16 equals opposite, which is x, over hypotenuse, which is 11. And again, I'm going to think of it as a proportion, and butterfly 1 times x is x, 11 times the sine of 16. That's just going to be calculator work. Put it into your calculator, and you should get that x equals 3.03. Okay, just a couple more examples here to make sure we kind of know how we're doing this. All right, first things first, where's my angle? I've got a 29-degree angle. Okay. X is opposite of it. 20 is across from the right angle, which makes it the hypotenuse. And that third side is the adjacent side, and we don't have any information about that. Since we know opposite and hypotenuse, we're going to use sine. So I'm going to say the sine of my angle, which is 29, is opposite, which is x, over hypotenuse, which is 20. And if I cross multiply, I'm going to say 1 times x is x, and 20 times the sine of 29. If we put that into our calculator, we should get that x equals 9.7. Last one over here. It almost looks like a 45, 45, 90 triangle, but it's not because it's 46 degrees. So identify our angle here, 46. Opposite of it is 18. And the hypotenuse is always across from the right angle, so we have hypotenuse. So I'm going to have the sine of my angle, so I have the sine of 46 equals opposite, which is 18, over hypotenuse, which is x. Now if you notice, if you look at all of the other ones that we've done so far, the x, the missing value, has been in the numerator, and it's been really pretty simple to just cross multiply and get your answer. When your x value is in the denominator of one of your proportions, it's a little bit more difficult because it's just a little bit more steps. So if you remember butterfly, okay, we're going to say 18 times 1 is 18. And then we have x times the sine of 46. Remember, the sine of 46 is a number. Okay, so we are just thinking about the sine of 46 as a number. So to get x all by itself, I would just divide both sides by the sine of 46. And then you can just put that in your calculator because the sine of 46 cancels. And if you put 18 divided by the sine of 46 into your calculator, you should get that x is approximately 25.02. Okay, so that's how we use the sine ratio to find a missing side length. Let's look at how we can use cosine. And again, these are going to be very similar, just different ratios that you're using. Okay, so up here I'm telling you we're going to use the cosine ratio to find the missing side. So first things first, just like we did before, I have my angle, which is 25 degrees. All right, this time if you notice, if I look across or opposite of it, there isn't any information there. We don't know anything about the opposite side. We do know that the hypotenuse is 12. Okay, and then this side is adjacent to my angle. It's touching the angle. It's right next to it. So since I know adjacent and hypotenuse, I know I need to use cosine. So let's go ahead and say cosine of my angle, which is 25 degrees, equals adjacent, which is x, over hypotenuse, which is 12. Because remember, in our formulas up the top, the cosine was the adjacent over hypotenuse. All right, so then if we think cross multiplying or proportionality here, 1 times x is x. 12 times the cosine of 25. You can put that into your calculator. Make sure you're using the correct trig function when you put it into your calculator. Don't accidentally push sine instead of cosine. And if you multiply 12 times the cosine of 25, you should get approximately 10.88. All right, let's move on here. Here's my angle is 27 degrees. 12 is adjacent to it. And x is my hypotenuse. So I know if I'm given information about adjacent and hypotenuse, I'm going to use cosine. And my angle is always attached to my trig function. Adjacent is 12. Hypotenuse is x. Now if you notice, we have a problem here again where our unknown, our x, is in the denominator. So it's going to be just one extra step. So if we cross multiply, we get 12 equals x times the cosine of 27. And we want to get we want to get x by itself, so I'm going to divide both sides by the cosine of 27. and put 12 divided by the cosine of 27 into your calculator, and you should get approximately 13.47 for a side length. I should probably point out also that you should double check to make sure your answers make sense. So if you notice, I got a side length of 13.47. Well, I know up here my hypotenuse should be my longest side. In any right triangle, the hypotenuse is always the longest side. So I notice my hypotenuse in this case is going to be 13.47, which is longer than 12. So I know I should have an idea of it being a reasonable answer. Okay, this one, anytime the triangles look long and skinny like that, it can be a little bit confusing. But here's my angle. Let's identify our angle. It's 72 degrees. Okay. Opposite of it, there's nothing labeled. That side is opposite. Across from the right angle is always our hypotenuse. And x is going to be next to it, so it is adjacent. Since we have information about the adjacent side and the hypotenuse, I'm going to use cosine. And again, always put my angle measure attached to my trig function, equals adjacent, which is x, over hypotenuse, which is 10. So we're going to have x equals 10 times the cosine of 72. And if you put that into your calculator, you should get approximately 3.09. And if you look at our diagram, 10 is the longest side, it's the hypotenuse, and 3.09 looks like a fairly reasonable side length for x. Okay, one more cosine here. We've got 61, 20 is adjacent, x is our hypotenuse. So we are going to have cosine, so we would say cosine of 61 equals the adjacent, which is 20, over the hypotenuse, which is x. Again, anytime you have that x in the denominator, it's going to be a little bit more difficult. So we have 20 equals x times the cosine of 61. If we divide that out on both sides, we should get that x equals approximately 41.25. Okay, so the last four here, you have to decide which trig function am I going to use. Okay, so let's go ahead. You have to decide, and again, let's put this down here. We've got, I'll put it off to the side here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Okay, so let's look here. Identify my angle is 69 degrees. Okay, I don't know anything about the side opposite of it. Okay, I do know that my hypotenuse is 10. And since this side right here is right next to my angle, this is the adjacent. If I know adjacent and hypotenuse, that is going to be cosine. Okay, so I'm going to use cosine in this case. So I'm going to say that the cosine of my angle, cosine of 69, equals adjacent, which is x, over the hypotenuse, which is 10. And we go cross multiply, x equals 10 times the cosine of 69, which is approximately 3.58. Again, looking at my side lengths, that makes sense. All right, so let's come on over here. Here's my angle, 35. My angle is 35 degrees. Oops, I look here, across from it, that's opposite. This one is across from the right angle, so that's the hypotenuse. And this side over here, which is adjacent, doesn't have any information. What we do know is the hypotenuse and opposite. So anytime, looking back over here, if we have opposite and hypotenuse, that means that we are going to use sine. So the sine of the angle, remember that angle is always attached to it. The sine is opposite, which is x, over hypotenuse, which is 10. And we've done enough of these solving, so I want you to go ahead and you can go back and put these into your calculator and solve and check for the reasonableness of your answer, but I'm not going to do that right now. Okay, so let's look here at number 11. I'm going to erase that just a little bit so we can see our numbers a little bit better. That was in our way. Okay, so let's identify our angle. Here's our 41-degree angle. Here, across from it is our opposite side. Across from the right angle is the hypotenuse. And this side that is right next to it and attached is our adjacent. Since I have information about opposite and adjacent, looking over here, opposite and adjacent, that means that we are going to use tangent. So I'm going to say the tangent of 41 degrees is going to be opposite, which is x, over 17, which is our adjacent. Again, you can go ahead and put that into your calculator. I should say tangent. And you should get, if you do it correctly, it should be approximately 14.78. Okay, so let's see, one last one here. Our angle is 71 degrees. Okay, over here across from it, that's our opposite side. We don't have anything that we know about our opposite. Across from the right angle is the hypotenuse. So we have the hypotenuse, and then this side here that's right next to it is the adjacent, which means if we have adjacent and hypotenuse, that means we are going to use cosine. So the cosine of 71 degrees is the adjacent, which is x, over the hypotenuse, which is 20. And if you put it into your calculator, you should get approximately 6.51. You have a class kick that goes along with sine, cosine, and tangent that are going to have problems like these last four, where you have to identify the sides and then which trig function you're going to use, and then solve for the side length. So you need to make sure you know and label and identify every single one of them on every single problem. Good luck.